Now see here in digital electronics and logic gates, here we are going to do the basic logic gates, and see, you know, the logic gates are actually the devices or the circuit which actually works on the certain logical relationship between input and output signals. So, we have seen till now the signals like this. If we are taking like these signals, these are the time varying signal, whether it is I or voltage, anything. These are called analog signal. But if we look at the binary numbers, and you know, in the binary numbers we use basically two digits like 0 and 1 for the, you know, the 0 voltage, and for the high you can give the 1, or we can say also here the, you know, the false or true, and also you can do as here the no or s. So, there are only two values, a specific level of the values or a specific level of the voltages here, which are here the 0 and 1, and in this case we can do like binary numbers. So, the signals which are representing binary numbers are called here the digital signals like this. These signals have like these values 0, 1, 0, 1 here. So, here we are going to deal with the digital signals in the logic gates. So, as I have told in the starting, logic gates work on the certain logical relationship between the input and output voltages. So, there are the three basic logic gates, but here we will be doing actually the 5 types of the logic gates. So, first logic gate we take as here, that is called OR gate. You know, OR gate is symbol is like this. Actually, this symbol consists of a electronic circuit inside it. There are the diodes used to, you know, justify this or realize this symbol. There are two input A and B, but one output, that is y is equal to A or B. We do not say like A plus B, that is A or B. Now, here we take signals like this is A, this is B, this is Y. Suppose we give here as the input 0 and 0, output we will be getting 0. If you are giving here this is the input, suppose 0, A 0 and B 1, then output is 1. And if you are taking 1 0 1, and if you are taking a 1 1, and then output is also 1. So, here in this case these are the 4 possible values for the input, and output we are getting here this. So, this type of the logical relationship is performed by this, which is actually consisting of the diode, and this gate is known as OR gate. So, we can say this is the first logic gate is OR gate, and that is y is equal to A or B. Here there are the two inputs, but one output. We can take another type of the logic gate, that is called AND gate. AND gate we can take like this. This is A and B, and here y is equal to A dot B, that is A and B. Here also we can perform certain logical relationship A, B and Y. Suppose A is 0, B is 0, Y is 0. A is 1, B is 0, output is 0, and A is 0, B is 1, output is 0. A is 1, B is 1, and output is 1. So, in this logic gate here we have seen here, these are the 4 possible values, and we are getting output only in one case. This type of the logical relationship is performed by this AND gate, and this is known as truth table of this AND gate. Now, the third one is that is called NOT gate, which actually reverse the input and output basically here. So, NOT gate is represented by like this, one input and one output, but it is a reverse of that, opposite to that. If you are taking A 0, this is A bar. So, here if we are taking this 0 1 1 0, one input one output. So, this work on this truth table or on this logical relationship. See, another type of the logic gates also here, which can be obtained by combining these two. Suppose if you are taking NAND gate now, See here in NAND gate, we take AND gate, this is A and B, y is equal to A and B, and here we use a NOT gate. So, that is A and B bar. Symbol we can give for this like this. So, A and B, that is A and B bar, this is here the NAND gate symbol. We can make it truth table. This is a combination of one and one NOT gate. Its truth table will be here if I take A, B, A and B and A and B bar. This is 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1 and 1, 1, 1 and it is here 0. So, actually output of the AND gate is applied to the NOT gate and whatever the here we get. So, this is called completely the truth table for the NAND gate. So, this is the obtaining NAND gate by using and NOT. Now, we can take similarly another one that is called the NOR gate, and in NOR gate we can take here one is OR gate, 2 input, 1 output, that is A or B, and here this is the NOT, A or B this. Its symbol we can make like this, A, B, A or B, that is bar. We can take A, B, A or B and its here bar, this is NOT, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0. So, this is the truth table for the NOR gate. So, we have seen here all 5 types of the gate, and now we will be here using NOR and NAND gate to obtain here the OR, NOT and AND gate. Now, see, we have done NAND gate here. So, NAND gate is like this, and this is giving here A dot B or A and B bar. There are 2 inputs, A and B. Now, if we combine these 2 inputs like this, here A or B, then make it truth table, this is Y. So, there are only 2 possibilities A, B, Y, both can be 0, 0 here 1 or 1, 1 here 0. So, this is actually behaving as NOT gate. So, we can obtain NOT gate by using NAND gate. Similarly, we can take NOR gate, and NOR gate if we combine, if here we combine input and output both inputs here, sorry, A and B, then also we will be getting this same truth table. So, it means NOR gate is also can be used to obtain NOT gate. So, this is the NOT gate obtained by NOR gate. So, this is the first example here. Now, if we take another one for the NAND gate only, I am here for the first applying NAND gate. In NAND gate, if you have taken, this is here A and B, and here we can take clubbed part these two, this one, two NAND gates. This is the NOT gate obtained by NAND gate, this is the NAND gate only. If we make truth table A, B, this is here A and B bar, and this is here A and B bar bar. We can write 0, 0, then A and B bar can be written 1, and this can be written here 0. Similarly, if I take here 0, 1, this is 1 and this is 0. If I take 1, 0, 1, 0, and this if I take here 1, 1, here 0 and this is 1. See here, this truth table is actually belongs to here AND gate. So, we have obtained AND gate, this is actually here AND gate from NAND gate. So, by using NAND gate we have obtained here AND gate. Similarly, we can get OR gate by using NAND gate. So, how do we get OR gate by using NAND gate? Just we take here these two NOT gate obtained by NAND. This is A, this is B, and they are used to feed here. This is another NAND gate. This is A bar, this is B bar, and then here we can write A bar and B bar whole bar. So, we can write A, B, A bar, B bar, A bar, B bar and this A bar, B bar whole 0, 0, 1, 1, and here this is 1, 0. We can take 1, 0, this is 0, 1, and this we can take a 0, 1, that is here 0 and this is 1. 0, 1 we can take here 1, 0, and here 1, 0 that we can take here the 0 and again is 1. 1, 1, 0, 0, 0, 1. So, this we are getting here OR gate. So, we have seen here how to get OR gate by using NAND gate. So, we can get all the three basic logic gates like OR, and NOT gate by using NAND gate, also by NOR gates. So, therefore, we can say NAND and NOR gates are the building blocks of the logic gates.